Hi everyone, it's Mrs. Summer here to talk about Unit 7 review. So the first part of this is simplify the expression and write your answer using only positive exponents. So to simplify our expression, for the first one, we have y to the third times y to the negative fifth. So our product rule is that we add the exponents. So we have y to the third plus negative 5. We get y to the negative 2. Like I said before, our exponents in this class have to be positive, so we would write this as 1 over y squared. Number 2 is, let's do it that way, x to the fourth over x to the seventh. So now we have we're dividing, so we're going to subtract our exponents. So we have x to the fourth minus 7 is equal to x to the negative 3, which is going to be 1 over x to the third. The next part is, number 3 is x to the 0 times x squared all to the third power. Now our power rule is that we need to multiply our powers. So we have x to the 0 times 3, y to the 2 times 3. So we have x to the 0 times 3 is just x to the 0, x to the 0, and then y to the 2 times 3 is 6, and x to the 0 is 1, so our answer is just y to the 6th. The next question is 2x squared over 5y to the fourth all to the negative 2 power. So let's do our power to our power rule. So we have 2 to the negative 2, x to the 2 times negative 2, all over 5 to the negative 2, y to the 4 times negative 2. Now, if we, 2 to the negative 2 is 1 over 4, x to the, so then this would be x to the negative 4, which would be x to the fourth on the bottom. We then have 5 to the negative 2, which would be, if it was on the top, we would move it to the bottom. Since it's on the bottom, we move it to the top. So we have 25, and then y to the 4 times negative 2 is y to the negative 8. So we move y to the 8th on top. Question number 5 is determine whether the table represents a linear or exponential function and explain your reasoning, and then make equation to model the table. So we're going to look and see so negative 2 to 0, you added 2. 0 to 2, you added 2. 2 to 4, you added 2. So because you're adding the same number each time, it's linear. So linear, added each value, same value each time. So our equation is going to be y equals mx plus b. And our m is our slope. It's what we're changing each time. So our y is equal to 2x plus b. Now, question is, what's our b-intercept? Or y-intercept, sorry. Our y-intercept is when x is 0. So if we continue this trend over here, negative 4. Because we're going to subtract 2 to go down, and we get y is equal to 2x minus 4 as our equation. The next table is, so 6, what do we do here? And then what do we do here? So 6 times what equals 12, or 6 plus, so 6 plus 6 is 12, but is 12 plus 6 24? No. So then we need to see if it's exponential by multiplying the same number. So 6 times what equals 12? Well, times 2. 12 times what equals 24? Times 2. 24 times 2 is 48. So this is exponential because you multiplied same number each time. And then the generic equation for an exponential function is y is equal to a times b to the x. Okay, A is our starting number, and B is our multiplying interval. So y is equal to 6 times 2 to the x as our equation. Okay, for the next two questions, they want us to use your graphing calculator to determine the regression values. So for question 7, I determined that the linear regression R value was 0.8345, blah, blah, blah. And then my exponential regression, my R value was 1. So this is a good fit for, this is an exponential because regression, because the R value is closer to 1. Over here for 8, it's a linear regression. The linear regression value is -1. And when I plugged it into my exponential regression to get that number, it gave me an error, which means that this is a linear equation. Because the R value is -1. So it's closest to 1 or -1 is the better fit. So the next part says, determine whether the table represents exponential growth function, an exponential decay function, or neither. So number 9 is a growth function, and it's growth because as you increase your x values, you are multiplying your y terms by 2. So it's growth. Over number 10, it's decay because as you increase your x values, your y values, you're multiplying it by 2/3. So you're multiplying it by a number that's less than 1. And so that number is getting smaller. And because the factor is the exact same, 2/3, each time it is a decay factor. The next part is determine whether the functions indicate a growth or decay and identify the initial amount and the rate of change as a percent. So number 11 is a growth, and it's growth because the number in the parentheses greater than 1. So your initial amount, A, would be 4, and your percentage as a decimal, so your R value, as a percent, it would be 0.25, and then as a percent, 25%. For number 12, your initial amount is 600, and this is a decay. The reason it's decay is because that number in parentheses is less than 1. So to find our R value, we need to do 1 minus 0.84, which is equal to 0.16, which is equal to 16% decay. So question number 13 says the value of a TV is $1,500. Its value decreases by 14% each year. So for 13A, it says to write an equation that represents the value Y in dollars of the TV after T years. So our A is 1,500. Our R is 15%, which is 0.15 as a decimal. So our equation is Y is equal to 1,500 times 0.85. I'm sorry, let me go back. 1 minus 0.15 to the T. We can simplify that as Y is equal to 1,500 times 0.85 to the T. And then it says to find the value after 3 years. So we're going to plug into our equation, Y is equal to 1,500 times 0.85 to the 3 years. And I just realized that it's 14% and not 15%. So that's a 4, 4, 4, and 86%. So 86, and then if I plug that into my calculator, I get, after 3 years, $954.08 is how much the TV is worth. And then part C says to how long will it take for the TV to be worth $600? So we're going to plug 600 in. I get 1,500 times 0.86 to the T power. So now we just need to guess and check for T until we reach approximately $600. So if you do that, you're going to get a T value of 7 years. So after 7 years, it will cost, or it would be worth about $600. Question 14 says the population of a city has increased by 2% annually. The population in year 2000 is 315,000. So for 14A, it says to write an equation that represents the population since 2000. So we're going to, our A value here is 315,000. Our R is 2%, which as a decimal is 0.02. And since it's increasing, it's a growth question. So our equation is y is equal to 315,000 times 1 plus 0.02 to the t. So then we have y is equal to 315,000, 1.02 to the t power. So letter B says, find the value of the city in 2021. So the population is in the year 2000. So how many years are between 2000 and 2021? There's 21 years. So we need to plug in 21 for our t value, and we get 315 times 1.02 to the 21st. And we get y is equal to 477,434.89. But since we're talking about people, it would be 477,435 people. And then the last question is, approximately how long will it take for the population of the city to be over 500,000? So here we would set it up as 500,000 is equal to 315,000.02 to the t power. And then we guess and check for t. So when you do that guess and check, you would get t is equal to 24 years. So 24 years after 2000 would be 2024, would the population be over 500,000. Question 15 says, what is the next three terms of the geometric sequence and find the common ratio? So our common ratio, we would take this divided by that. So 20 divided by 5 is 4. 80, and test double check, divided by 20 is 4. So our common ratio is 4. So then we're going to take that 320 and multiply it by 4. So we get 1280. Then take that number and multiply it by 4. We get 5120. And then multiply that number by 4, and we get 20480. So question 16 is the same thing, but let's see. We have 12 divided by -3 is -4. And then we get -48 divided by 12 is -4. So finding the next three terms, so our common ratio in this one is -4. So I'm going to take 192 times -4, and my next term would be -768. Multiply that by -4, I get 3072. Multiply that number by -4, and I get -12288 as that third term. So number 17 says to write an equation for the nth term of the geometric sequence and then find a to the 9th. So first we have to find our common ratio. So we have 4 divided by 1 is 4. 16 divided by 4 is 4. So our common ratio is 4. Our starting number is 1. So our a to the n is equal to a to the 1. So 1 times our common ratio, n to the -1. And then a to the 9th, so a to the 9th is equal to 1 times 4 to the 8th. 4 to the 8th is, so a to the 9th is 65536. The last question, we need to find our common ratio. So 162 divided by 486 is 1/3. So that's 1/3. This is 1/3, 1/3. So our common ratio is 1/3. Our starting number, so a to the n, is a to the 1, which is 486, times 1/3 n to the -1. So then if we do a to the 9th, get 486 times 1 over 3 to the 8th. We get 486 times 1 divided by 3 to the 8th power. I get my a to the 9th is equal to 2 over 27.